Hi. Today we're gonna talk in this video we'll be talking about chapter 2, function and graph. First, let's talk about the translations in graph. One, horizontal shifts. It happens when the original function is y equals fx, now changed to y equals f function of the x plus c. So before x, x becomes x plus c. For example, fx equals x squared, and now it's changed to f of the function of x plus c, so which is x plus c to the square. So when x is greater than 0, it shifts to the left with c units. When c is negative, it shifts to the right with c units. For example, before, the point where fx equals to 0 is when x is 0, right? Now we want fx plus c equals to 0. We need x equals to negative c. Okay. Next is the vertical shift. It happens when y equals to fx becomes y equals fx function plus c. When c is greater than 0, it shifts up c units. When c is negative, it shifts down by c units. Simple. Vertical stretch and shrink. So when c is greater than 1, the original function was y equals fx, and now becomes y equals c of fx, c times fx function. Okay, so when c is greater than 1, it shrink it to be fatter or larger. For example, function of y equals fx equals x squared now becomes y equals 2fx equals 2x squared. The function before was like this. Okay, so here is 1, 1, 2, and 4. Now it becomes when x is equal to 1, y is equal to 2, x equal to y equals 8. So it becomes like this. It's shrinking. Sorry, it's not getting fatter. It's shrinking and it becomes smaller. Okay, when c is smaller than 0 but greater than 1, smaller than 1 but greater than 0, it stretch becomes fatter like this one here. Like these ones here. Okay. Horizontal stretch and shrink. The function before was y equals to fx, now becomes y equals f function of c times x. Okay, when c is greater than 1, for example this one, it stretch to the inside. Okay, becomes smaller. When c is greater than 0 but smaller than 1, it shrink to the outside of the function y equals. Okay, got it? The reflection about x-axis and y-axis. When y equals to fx becomes y equals negative of fx, it's a reflection about x-axis. The example is here. When y equals x squared becomes y equals to minus x squared, it's a reflection about the x-axis. 2, I'll change another color. 2, when y equals to fx change to y equals to negative x of function, it's a reflection about y-axis. The example is here. Before it's y equals to square root of x, now it becomes y equals the square root of negative x.